You know, weirdly enough, some people do. Not even kidding you. Okay, now we have worked with side, 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 and angle, side, angle. Those, if I gave you everybody, okay, you need to draw me a triangle with this angle, this enclosed length side, and then this angle, you'd all come up with the same triangles. Now, someone always argues, yeah, my mine's upside down than his, so it's a different triangle. And I would argue back, if you move your couch in the living room, it is the same couch, okay? That would be my argument, okay? Doesn't turn into an elephant, right? Which would be very inconvenient, sitting on an elephant, watching TV, especially if you don't have 10-foot ceilings. You know where I'm going with this, right? Now, yeah, I'm recording. Now, as we're doing this one takes you to be really thinking about how that could be, okay? Now, remember, as you're thinking about these, you have to make certain assumptions, and the other ones you don't want to make assumptions on, because that's what usually steers us down the wrong path, is when we make one little assumption and then we go with it. Like I used to give this, I used to do these lateral thinking questions, and the lateral thinking question that messed up students the most was this one right here. Now, if you know the answer, don't say the answer to it, but there's a cabin in the woods. So you picture it. Okay? And you walk upon it, and the door is locked from the inside, right? So you and your buddies grab a big tree and you bust it in. You go in there, and there's 3 people dead. Okay? And the question is, what happened? Okay? Now, and then I say, I'll give you, and then I give them hints, right, after the game. And I go, okay, if they would have got out 2 hours earlier, they would have survived. Okay? So then starvation doesn't become the, and then I say that they did not kill each other. Okay, so then you get a few more. Okay? And it was a pretty bloody death, broken bones, a lot of blood. It was locked from the inside. Okay, the bear was not in there with them. Okay, what happened? No, they've been dead for a while in there. It's kind of crusty and smelly by this point, yeah? So, are you saying a plane crashed into the cabin? Okay. What are you saying? Aaron actually has the right answer. So, it is a plane crash, and right when I say that, people go, so a plane crashed into a cabin? Right? And no, it is a plane cabin. Okay? So they come across a cabin in the woods. So right away, if you pictured that nice little cabin, who pictured it, and a little smoke coming out of the, nice and cozy inside, maybe a little wood stove, bearskin rug, once you have that in your head, it's hard to get out. I'll even have students come to me later and go, like, I don't get how the plane smashed into the cabin, but it was locked from the inside. Like, wouldn't the cabin have been busted, right? There's no log cabin there, okay? It was a plane cabin, okay? But I'll tell you, unless you get rid of that assumption, you'll never get that one. And what's the assumption? That nice log cabin, okay? How about this one? Okay? You're walking along in the woods, and you come across this cabin, okay? And you're freezing cold, and you get into this cabin, and there is a wood stove, a coal stove, and a gas furnace. Which one would you light first? And there is a right answer. but why? You have a coal stove, and if you know the answer to this one, don't give it up, okay? There's a coal stove, there's a gas stove, or sorry, a coal stove, wood, and a gas furnace, okay? Which one would you light first, and why? Okay, just think about it for a sec before I ask for answers. Okay? So those people that know the answer, what's the answer? The match. Okay. So today we're going to be working with side-side angle. Now that can also be angle side-side, but because they're a Christian school, I'm not allowed to write that one down. Some people are still going, what? You get it? Okay. Yeah, yes, this is known as the postulate, okay? So, but let's call it side-side angle. Let's keep it clean. Because actually, we're going to deal with the side-side angle. That means if you're given a side, and it must be attached to the other side, and then the third one has an angle to the side that can be any length in the world, okay? So what I'm trying to say here, I'm taping, so I can't do it on the board, but here's a side, here's another side, and then there's an angle that's given. And then that side, we don't care how long it is, it can go forever, okay? Just go forever and ever and ever. But that angle has to be kept. And it's asking, give me a triangle. So Scott and Brittany were given this assignment, and they were given like 2 popsicle sticks and a protractor. So those 2 popsicle sticks had to be joined, and a protractor, and then that third side was drawn. So draw me a triangle that has basically a 6, 4, and a 30 degrees. See how it's side angle? So these were the 2 they came up with. Scott did his 4, 6, 30. Brittany did hers 4, 6, 30. But they're totally different triangles. So, you know, with side, angle, side, and angle, side, angle, there's only one triangle you could ever draw if I gave you those 3 things. In this one, there's actually 3 scenarios. Sometimes if I give you a side, angle, there's 2 triangles you could draw, okay, right here. There isn't 20, there's only actually 2. Sometimes you can only draw 1. And sometimes you can't even make a triangle. What we're going to go through today is, well, how do I know? Like, do I have to draw it every time and get my protractor out and everything? Now, as ridiculous as that may sound, yes. If that works for you, because I will do that. Like if it says 30 centimeters and 20, I'll do it 3 by 2. Okay, and see if it would actually work. Because I'm a very visual person. Okay, if I was in a staff meeting and they're like, yeah, here's the 10 steps to take your marks from Power School and get them into School Zone. And believe me, there is 10 steps. Those 2 programs do not like to play with each other. It's kind of like Google and Apple. They don't like each other. They're always kind of, right? So I'm like, you know, instead of just telling us, can you send us like an email with all the steps written out? Step 1, do this, do. And then usually there's a couple people going, yeah, that would be awesome. And then I get it, I see it, and I can do it. No problem, okay? You're wasting your time telling me. Like, unless you can show me while you're telling me. And that's why everything I try to do in this class, the auditory learners can get it from me talking, even in the video at home, but the visual people really need to see it, okay? So I'm going to always do a visual. And doing a visual, you'll know the answer probably already, but you still have to prove it mathematically. And I'm going to show you how to do that too. I'm going to show you the rules. You're going to write these rules in your study sheet. You're going to know them forever, or at least for the test, right? So I just wanted to show you, here's a time where you will get 2. Well, can we see a time when you're going to get just 1, or can I see a time where you get nothing? Because I'm not really getting you right now. I get the 2, but how would this work if it was nothing? Okay? Well, what I'd like to do is actually go to 199. Okay? And I actually have I'm just going to show you really quick. See this ruler? Do you see how it's touching? I got the 0 here. So this is my length. Okay? Now, the question would be, when would there be 2 possible triangles? Well, I think there would be 2 possible triangles if, say, that side was 3 centimeters long. Do you see how I would have that one and this one? How about 4 centimeters? Yeah, I would have that one and didn't quite draw that long enough. Oh, yeah, I would. Yeah. See how 4 centimeters would make 2 triangles? This one and this one. Do you see how I've hit 4 twice? Okay. Look at the 4 on the ruler. It hits there and there. So A4, and this is supposed to be, they don't even tell me the length of this one, but basically this is where you get your side angle. So if I was told, well, that side has to be 4, or even 3.5. You see 3.5 hits there and there. So that would give me 2 triangles. Now, when would I only get 1? Well, there's kind of 2 scenarios. I would get 1 when this is 90 degrees. Do you see that? Like, how am I going to get another one? Here's another time I would only get 1. Is this is 6 centimeters long. Do you see how? No, that's not good. Do you see how if I'm going to have to pull this up, and that's why I always make this side infinitely long when I draw these triangles, and obviously not infinitely long because it would take me forever. But I draw this one quite long all the time because I don't care how long that side is. I don't have to fit that as my requirement. It's side angle. That other side's irrelevant. But do you see how? Oh, making that okay. A 7 would hit. See the 7? See how it hits? Would it ever hit again anywhere? Because if it's longer than that other side, do you see how it would never hit? So that's when I would get 1 triangle. Either if it is longer than this side, because see how 7 never hits again. Or if it does hit at a 90. Now when would I get no triangles? What would the length of that ruler have to be to give me no triangles? 2, right? You see 2 would not, see how 2 is never going to give me a triangle? Is everybody seeing that? 2's never touching. See the 2 on the ruler? It's never touching. So if that was a 2, 5, 30, never going to happen. I'm not going to get that. If it was a 4, 5, 30, you see how 4 would actually hit twice? It would hit there, and it would hit there. Okay, so that's just kind of a brief rundown. I'm going to show you now mathematically how to prove this. So let's go over here. Now, here is case 1 where they say so I'm on page 200. It says make AC equal 2.5. I don't even have a C on here, so what are they talking about? But I'm going to show you how to do these. Now remember, this one, I hate how they make it short, little thing like that. They should have made it like this. That's how long I always make that one. I always draw these the same. I put my angle right there. See how I put my angle? Now, they're saying I want you to do SSA. So our SSA would be, and they said 2.5, right? So 2.5, 3, and angle is 30 degrees. So they're like, draw a triangle, 2.5 by 3, and then a 30 over there. Do you see the side angle? Okay, now, 2.5, if I measured it, hits twice. It hits here, and it hits about here. It doesn't look right, does it? It's more like over here. Okay? So this was 2.5. Okay? Now, it says use the sine law to find angle C. Now, see how it makes two triangles? If you use the sine law, it will always find this angle, not the other one. I'll show you how to find the other one after, though. It'll just find the one. Now, remember this. It says find angle C. Well, I know this loop. And I am only missing one of that loop. So I can go find angle C. Does everybody see, remember what I'm doing here? So let's go find angle C. What would it be? Okay, so then you'd go sine C over 3 equals sine 30 degrees over 2.5. Okay, now everybody should know how to do this, and I want you to find angle C. What are we getting? 36 point. Yeah, let's round it. So you should get 37 degrees. Now, so let's up on our diagram here, just put a little arrow. That is 37 degrees. Now, here is the secret. I'm going to give you the secret. To see how 37 is bigger than the angle given? Angle given is 30. And if you test enough of these, you'll find that whenever that angle up there is bigger than the given angle, it always makes two triangles. Now, we don't have the time to mess around with that. I wish we did. But if you want to test this throughout the whole thing, you'll always find if that angle is bigger than the given angle, it always is two triangles. Okay? So I want you to write that down right here. So angle C is greater than angle B. So 37 degrees is bigger than 30 degrees. Now what we just found, this is called the reference angle, okay? So if the ref is greater than the given, so if angle C is greater than angle B, or if 37 degrees is bigger than 30, or if the reference is greater than the given, I basically said the same thing 3 times, right? Everybody get that? I'm just saying the same thing 3 times. Then there are always two triangles, and there is two triangles. Always, always, always. So I've given away the ending. And how would I have loved to do this? I would love to actually, you guys, okay, draw this triangle in pairs. What'd you find? You know, if we did that enough, you would get the pattern after a while. Hey, every time we did these, that angle was always greater than the, okay? Now, the $1 million question would be, how do you find this other one? So we know how to find this one. These two are what we call supplementary. Supplementary means this angle here plus this angle here always add up to 180. Okay? So the way you find that angle, so by that angle I'm talking this one, this is 180 degrees minus 37 degrees. That's 143 degrees. Now with that, can you find angle A if you needed to? Yeah, you just subtract from 180 even to find angle A. And angle A will have two answers, will it not? Because there's angle A for the big triangle, angle A for the little triangle. Right? And we'll do some examples later. Now you get to see specifically, well, what happens if we make AC 4 centimeters? Okay, now I'm hating this line, so I draw it ridiculously long, okay? Because that side's allowed to be anything, so if I go long, okay, now 4 centimeters. Now, can you picture where I can start drawing 4 centimeters? If, say I have, let's do, see how this is 4 centimeters, this line? That's about 4, right? Does that look like about 4? What if I took this, just started rotating it? Where's it going to hit? For the first time, it'll probably hit over there. Do you see how it cannot hit before that point? Because it's actually longer than that side. So that's a 4, 3, 30. Side-side angle, 4, 3, 30. Now, the question is, how do I know for sure that that is the only triangle? Okay, so let's go find angle C again. Okay, so if we go sine C over 3, good, centimeters, equals sine 30 over 4. Okay, what do we get for an answer? Yep. So angle C equals 22 degrees. So whenever you use the sine law, you find that angle is less than the given angle. So let's do it 3 times. Angle C is less than angle B, or 22 degrees is less than 30 degrees, or the reference is less than the given, and there's only one triangle. Okay? So now you're getting some rules. If I do it and that angle's greater, oh, then there's 2 triangles. If that angle is less, only 1 triangle. Third scenario. Okay, so draw this side infinitely long. Now make it 1 centimeter. Okay, now what you do is you draw your line 1 centimeter long. Okay, so if I draw it like 1 centimeter long, there it is. And then what you do is you start rotating it until you hit. Like the other ones, we hit here and here, right? The first one. The second one, no, 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 and then finally hit. Like finally the 2 ends touched. Here, do you see what's going to happen? What's going to happen? It's not going to touch anywhere, okay? But we have a theory for when it's going to hit twice. We have a theory for when it's going to hit once. What answer would I get in my calculator to go, it's not hitting at all? Because I want to have that, right? We all like that stuff. We need definite ways to get stuff. And that's how we should be, okay? It's some things take a lot of faith. We don't like that in math, do we? Okay? So let's just do this. Sine, now we're still doing angle C. The angle that, like what angle are you talking about? Don't things have to touch to be an angle? Yeah, but let's just humor me, because you would still have to do this as a proof. So sine C over C equals, oops, no, I should actually put stuff in. Sine C over 3, right, equals sine 30 over 1, not 2. because that's 1 centimeter there, right? 1, 3, 30. What does angle C equal? Nothing? 0? Error, right? Okay, that's good. That makes sense, doesn't it? That's probably the one that makes sense to everybody. Well, you didn't get an angle. Good. Okay? There's times when this is one time where it not working verifies what you're thinking, right? So if reference angle does not exist, there is no solution. That triangle cannot be built. Okay? So, if you couldn't mess with the 1, what are 2 things in that triangle, 2 things you could change to make that triangle happen? You can't mess with the 1, though. What would you do with the angle? You'd make it less. Because if you made the angle less, okay, again, just humor me here. If you made this angle less, oh, you're bad. You see how it would hit? What's another thing you could do if you didn't change the angle? Shorten the 3. Do you see how as that thing came? It would finally touch. Now these are kind of questions that are fair to ask on a test. Okay? Angle, or, side opposite the given doesn't touch. What are 2 things, or what's another way you could make this triangle? Well, you could lessen the angle on that infinite side, or you could shorten that given side from 3 to 2 to 1. Okay? Whatever you got to do. Now, here is everything summed up right here. Okay? Now, this is called the ambiguous case for the sine law. Now, you know what the opposite of ambiguous is? Definite. What is the answer? Well, this one, if you get side-side angle, what's the answer? Well, it could either be no triangles, 1 triangle, or 2 triangles. That's why it's called ambiguous. Until you actually sit down and think about it, draw it, or do some math, you can't say for sure. That's ambiguous. When someone gives you an answer, they're kind of like, hey, do you want to do something Saturday? Well, I might have to go to this place. I might have to work. I might have homework. You're being very ambiguous. And at that point, you're probably guessing, yeah, in other words, you're trying to say you're busy. I get it. Okay? So, but if someone gives you a definite answer, I have to work Saturday, can't. Okay? Then you're probably, maybe you wouldn't take that as bad. Oh, okay. Well, it's cool. You got to work, right? So, when you're definite, it's a side, side, side. Side, angle, side, or angle, side, angle. Those are definite triangles. There's only one triangle you could make if I gave you an angle, side, and an angle. But if I gave you a side, side angle, 0, 1, or 2. Okay, so here are the sentences that you need to know for this one. Number 1, if the reference angle is greater than the given angle, there will be 2 solutions. Now, with this, let's include a picture. So we have this and this that I would do in like blue, and then maybe I have this and this as my 2 angles. So this one is called the reference, right? And this is called the given. Okay? Now, how do you find this one again? This guy right here? Who remembers how? 180 minus reference. Good. 180 minus ref. And there's even one question in the homework that asks you this angle right here. Now, if you know this one and this one, you can find that one. Okay? So there's my picture that goes with that one. Now, what if your reference angle is less than the given angle? one solution. So maybe this is that side right here. Okay? So there's one solution. Oops, I guess I should have put that there. Save some time. Okay? And if the reference angle does not exist, there will be 0 solutions. Okay? So this I've hopefully demonstrated pretty good. You got this? No, not happening. And here's my side-side angle, right? Here's my side-side angle. Here's my side-side angle, or side-side angle. Yep. The smaller angle will always be the one your calculator gives you. It will always give you that top one if there's 2. Okay? And again, write these things down, because in 3 months you may not remember this. They're those little things that always get you in math, right? But you got to know that that's the top angle it'll always give you for the 2. If it's the one angle, obviously it's the one angle. You're not going to get that one mixed up. And if it doesn't give you an angle, you're not going to mix that one up either. Okay? Now, this is if you know angles. What if you only know sides? Okay, so this down here deals with the sides. Now, if the sine opposite the given angle is greater than the side given. So if the side opposite the given angle, okay, so when we talk about opposite, this is the given angle, right? So they're saying if the side opposite the given angle, so we're talking about this one, if it's greater, say this is 5 and this is 4. So this is what this is saying. If the side opposite the given angle is greater than the side opposite the reciprocal, or the required angle, there's only one solution to the problem. Okay. Now remember, this one is called the required angle, or reference angle. So if the side opposite the given is greater than the side opposite the reference, how many triangles? There will only be one triangle. See, it's not even talking about angles, is it? But it's true. Every time that one's longer, there's not another time I'm going to touch. And I could guarantee if I go solve it, I'm going to find that reference is smaller than the given. Right? Now what happens in the second one? If the side opposite the given angle is less than the required. So what if we have this, okay, and say this is like 10. If the side opposite is less than, so say this is 6. Now here's the given. So if it's shorter, what are my possibilities? 2 or none. There is no way to tell, unless you kind of try to draw it. What is the only way to tell for sure? How do you check? Use the sine law. If you get an angle greater than the given, 2. If you get an error, none. But be careful, because sometimes we put stuff in our calculator wrong and get an error, right? It doesn't mean that there's no angle there. Maybe you put it in your calculator wrong. Okay? So that is the ambiguous case. So we're just going to do a couple examples here. Now, number 1, it says without using the sine law, but we are going to use the sine law because I'm going to do kind of 1 and 2 together. So we're just going to do 1A and B. Now, so calculate angle C in ABC where angle B is 56, C equals 10, and B equals 12. Now, these get confusing without a drawing. Okay? So I always try to stay very consistent. I always put my unknown angle. So I got this thing. And I always put my unknown angle where they've always been. And remember, this one goes on forever right? And this is angle B, and this is 56 degrees, okay? So I always put my angle there, and then it really helps me find out where side B is, right? Because side B has to be like here somewhere, correct? Right, we know that. And it's saying B is 12. And angle C is 10. Now, for this to be side-side angle, this would have to be the 10, and this would have to be the C, right? Okay, so we're always going to do it where that one is the infinitely long one, and then we can keep this consistent. Now, just by looking at it, how many solutions do you think we'll have? We'll have one. So I always do a drawing. Now, is that drawing to scale? No, it's horrible. Okay? That drawing, you know, that's not good. And you know what? I did that like I would regularly do it. Yeah, sure, I do. In my notes, I have the perfect picture right here. And you know, if I would have done the perfect picture, I would have probably made more people confused because they're like, did you just get that from the... no, I draw them the same way every time, actually. And I put the 12 there, and you probably measure, if you measure my 12, it's probably not even longer than my 10. Maybe it is, okay? But my point is, when I see the number 12 is bigger than the 10, I know there's only one solution. So maybe that thing is more like this, you know, who knows, right? So that, okay, I fixed it. I'm so smart, right? If I would have done that right off the bat, I probably would have confused you more, because it's like, how do you know? Like there must be a way to know that, right? So now I know, in my head, I'm seeing one solution. I'm going to use the sine law. What should I be getting for an answer if I use the sine law? It should be less than 56. If that's true, then my drawing makes sense. Okay? So let's do sine C over C equals sine B over B. Okay? So sine C is my unknown over 10 equals sine 56 over 12. Because remember these two and these two, right? What does angle C equal? 44 degrees, okay? Okay, now that's good. That verifies it. Because I don't want you, there's nothing worse than being on a test and going, like, yeah, I hope it's that. I have no idea. But you do your drawing. You know what? Students in the last class, can we bring a ruler and a protractor to our test? Absolutely. Do you get to bring it in the diploma? Yep. Okay. Do you get to bring it into my unit exam? Yep. Do you get to bring it into the final exam? Yep. All those tools are allowed. Okay. Rulers, protractors, right? So on the quiz that I gave you, you could draw them out. On the test, there's enough room to draw them out. Okay? So you should know the answer before you get it. But maybe 44 is a little strong to say, yeah, well, 44, I knew that. But it's less than 56, so that's cool. Okay, let's do another one. PQR, oh no, it doesn't have ABCs in it. Okay? Okay, so they do give me my angle though, 41, and like I do the same thing every time. Okay, so the more consistent you are doing this stuff over and over and over again. And yeah, I draw this thing ridiculously long, okay, because I need it to work. Okay, so this is, you know why I know this is P? Because it's the middle letter of QPR, remember? So that's my 41 degrees. Now, remember, I'm doing that side is the longest, so now it's going to be side-side angle. It says RQ equals 3. So I know this isn't RQ, is it? I mean, how am I supposed to make this RQ? There's a P there. So RQ has to be this one here. Okay? So, you know, and I don't make it touch all. I just go like this. This is like RQ. Okay? Well, actually, no. See, and then that doesn't make sense either, because now my So I'm going to like erase this and make this. This would still work, right? That's still RQ. Now why have I changed it? Because then it says PR resistant. I always like that to be my infinite one. So I change it for me. It's my test. It's my mark, okay? So I change it so it always looks the same. See, if I would have put the R up there, then my dotted line has a dimension of 4.2, and I don't want that. I want this to be 4.2, and this is 3. Okay? Now, right off the bat, how many solutions? 2 or 0. Does that make sense? Okay. So that might be all the question ever asks. And I will draw it every time, just in case. So I drew it, I'm going to get 2 or 0. I know that. And it makes sense, right? The 3, is it going to hit twice, or is it not going to touch at all? Because I didn't use a protractor here. Now, if I would have used a protractor and did the 41 and do that, then I would know, okay? There's always room of 4.2, you draw it, your 3, hey, it touches twice, hey, it doesn't touch at all, okay? So let's do it. Let's find the reference angle, right? I should have called that the reference in this one too. So the reference, I got sine q over 4.2 equals sine 41 over 3. Okay? What does angle q equal? Did you get an answer? 66 degrees, isn't it? Is it 67? Oh, the last class lied to me. You guys? Okay, I'll have to chat about that one. Okay, so that just gave me this. That means there is another one, right? How do I find the other one? 180 minus 67. So, or angle Q could equal how much? 113 degrees. Okay. So, this is one of these that I would love to have had more time to talk about it, but remember, if that angle is greater than, how many solutions? 2. If it's less than, 1. And if there is no answer, 0. Okay? So, something maybe to get on a study sheet. You'll either get it right tomorrow or mix it all up. So we are doing 1 to 6, but you can omit 4. So yes, it is as short as it sounds. And you have 15 minutes to do 10 minutes of homework. Yep. Yeah, I will. I'll just let me scroll through this so I can actually have people at home sick right now that are waiting for this one.